YouTube? YouTube! This is Mr. King coming at you from the classroom, not the studio today. I'm a little bit under the weather, so yeah, I'm going to record the lesson. It's really important they understand this because, like I said right here, there's going to be a quiz on Tuesday. So I want to just make sure it's crystal clear, and since I won't be able there in person to teach you, I'm going to record a video, and hopefully the video helps or is even better than having me in person. We'll see. Okay, but first, this is the do now. So I want you to think, would you just live in the city or the country? And this star is very old. I want you to think, what changes inside the star that changes the color? Just think about chemistry in general. I know that your sub knows chemistry really well, so your sub is able to talk about that because we went over yesterday that over time with fusion, there will be more hydrogen when it's younger, less hydrogen when it's older. So try and think what could cause the color to change. And then last question, review from yesterday. Voltage is V, resistance is R, current is I. If you increase the battery's voltage, which two letters will go up? Okay? And then next, you're going to need this packet. It looks just like this. Okay, it should have been handed to you, and you're just going to follow along with me. But I want you to know that science fair work day on Friday and circuit quiz on Tuesday. The quiz will be based on your homework, and we're going to learn more about parallel versus series circuits. And first thing, I want to give you the voltage formula. This formula is super important. You don't have to memorize it. If you do want to memorize it, you can just memorize VIR, or V is I times R, V is voltage, I is current, R is resistance, units, V is for volts, I is for amps, R is the symbol omega, but it's ohms. And we use that little horseshoe when we're drawing resistance. And then using this formula, here's a problem. You have a series circuit with one light bulb, and it has a resistance 0.75, and the current is 10. How many volts is the battery providing? You'll need a calculator, or maybe you won't. Whatever you think, can you put it for number 1? Okay? And then I posted these slides if you need more help. And I'll also give the sub the answer key. Okay, next. This is for number 2. This one, you have to work backwards. You have a 2.5 volt battery, and you have a light bulb that's 0.2. Now this time, what's the current? So we have the volts, and we have the R, but we need the current. So you need to use your algebra skills to try and get the I. Rearrange the formula to solve for the current. And please pause the video now and try and answer number 2. So after you resume, at this point in the video, you should have 1 and 2 completed. Okay, great. Next, this is going to be for 3A. This is the formula for series circuits. You do R1 plus R2, and if there's more, like if there's 5 resistors, you just keep going. So that's why I put N for like however many resistors there are, you just keep adding them. The series ones are very simple. You just add the resistance for each one. And then this is going to be for 3B. So we're going to practice this formula. If you have an 8 volt battery hooked up to 2 resistors, if this one's 4 and this one's 2, what is the current? So you're going to need I equals V divided by R. You'll need the VIR. You'll need this formula from the beginning. You'll need this formula. And now you'll need this formula to solve this one. So this one is a little bit more complicated. Step 1, can you get the resistance? So if this one's 2, and if this one's 4, this one's 2, the total you should get 6. 6 resistance. The volts is 8. You need to use your algebra to try and get I. And if you did it right, you should get 1.3 or 4/3. Great. So put that for 3B. You should get 1.3 amps. Pause the video now and make sure you have 1 through 3 completed. Next, we're going to step it up and make it a little bit harder. Okay, so 1 through 4 is a 2-volt battery. Each resistor is the same. We don't know how much each resistor is, but we do know that the current, if you measure the current, you find that the current is 0.25 amps. So the whole thing is 0.25 amps. The battery is 2 volts. My question for you is split into 2 parts. Can you find what's the total resistance and what's the resistance of each of the resistors? So this one was tricky for my first period. So I want you to just think about it. Pause the video now. Try and think. I have the voltage and I have the current. How could I get the resistance from that? So pause the video now. Try and think about it and answer 4A. Try and answer 4A. And then once you resume the video, you should know that you need to use this formula. We know the volts and we know the current, so you can solve for R by dividing. And then you should get the total resistance is 8. So the whole thing's 8, and each resistor is the same. So 8 split 3 different ways is 8 divided by 3, or 2.67. So for this one, we had to use both formulas. We had to find the R is voltage divided by current, and you should have gotten the total R is 8. And then the total resistance is this one plus this one plus this one is equal to 8, and they're all the same. So 8 thirds plus 8 thirds plus 8 thirds, you should get 8. That one was tricky. So now you should have 1 through 4 completed. And this is the answer for the last one on the front. So for this one, you need to draw. On the quiz, you'll have to know what a series circuit looks like and what a parallel circuit looks like. So this series, it's in a line. And this is parallel. It's looped, or the lines are parallel. It's okay if the lines aren't straight when you draw them, but you need to show that the current has to go through both of these. And this one, the current goes through R1, or it will go through R2. So the current will go this way, and then some of it will go through R1, some of it will go through R2. That's how they're different. But I want you to know what each one looks like. Next, on the back, on the second page, we have a new formula. Okay? This one is the parallel formula, and it is tricky. It is going to have a lot of fractions. So I don't know how you feel about fractions, but you're going to be doing a lot of them, so you're going to get better at it. And you're also going to be learning about negative exponents a little bit. So for the parallel formula, can you put on your paper at the top, the parallel circuit formula is 1 over the total resistance equals 1 over R1 plus 1 over R2 dot dot dot. And my first period asked me, why is it dot dot dot? The answer is because if there's more resistors, if there's more branches, you just keep going. 1 over R3, 1 over R4. But at the end, you have to make sure that R1, the total, is going to be on top. So we're going to practice. Practice makes perfect. So this question is, what is the total resistance in a parallel circuit like this one with 2 light bulbs, and each one is 3? Each one is 3. So we're going to plug it into this formula. So R1 is going to be 3, R2 is going to be 3. So you do 1/3 plus 1/3. So on your notes for number 5, you do 1/3 plus 1/3. And you should know if you have 1/3 of a pizza plus 1/3 of a pizza, you have 2/3 of a pizza. And that's 2/3. But at the end, I want you to notice that the total R is on the bottom. We need the R to be on the top. So at the end, we have to flip it. So even though we did 1/3 plus 1/3, we got 2/3, we're not done. We have to flip it at the end because the R is on the bottom. So for the parallel formula, you need to do 2/3 to the power of -1, which is the same as flipping it. And then you should get the total is 3 over 2, or 1.5. So the answer for number 5, the total resistance is 1.5, or 3 over 2. And that's how we did it. Just to recap, we did 1/3 plus 1/3 is 2/3, and we flip it, and we got 3/2. Okay, now I have another question for you. What is the current? The current in this setup, we have 3 resistors in parallel, and each one is 4. So this one, you're going to do 1/4 plus 1/4 plus 1/4. 1/4 plus 1/4 plus 1/4. You can think of it like you have 3 quarters. And then 1/4 plus 2 quarters plus 3 quarters, that's 3 quarters, or 3/4, 75 cents, 3/4 of $1. So 3/4, but then don't forget we have to flip it. A lot of students forget to flip it at the end, but that's because the total R is on the bottom. We need the total R to be on the top. So 3/4 flipped is 4 divided by 3. So the resistance, you should get 4/3. And then pause the video now, try and get the current. We will need to combine this formula, the formula from the very beginning, and the new formula we just learned, the parallel formula. Once you get the resistance, you have 4/3, and then you plug it back into this formula. V is I times R. We know V and we know R. You rearrange the formula to get I, and you should get 4 volts divided by 4/3 is 3 amps. So that is the answer for number 6. For number 6, the current is 6. For 6, it is 3 amps. Just to recap, we did 1/4 plus 1/4 plus 1/4, and you got 3/4, and then you flipped it to get 4/3. And then we plugged it back into the formula from the beginning. And if you need to rewind, I went through that problem a little bit too fast. So if you need to rewind the problem. Okay, and now we're going to be on the homework. And this homework, it is very important that you do it in class because I learned that it's very tricky, and it will help you get ready for the quiz on Tuesday. So, first problem on the homework, what is the current in each setup? So we have to do 2 different circuits, one for the series circuit on the left and one for the circuit, the parallel one on the right. Here's the question. If you hook up a 2-volt battery to 2 lights of 2 ohms each, so each light is 2 and the battery is 2. 2 light bulbs are in series, 2 light bulbs are in parallel. Calculate the current for each circuit. Okay. This is a lot. We're going to have to use all 3 formulas that we learned. Let's start with the series one, because this one was a little easier. Step 1, let's do the R series formula. So remember, R1 plus R2 is the total. So in this case, the total resistance is 2 plus 2. Because they're in series, we just do 2 plus 2. So I'm going to give you a sec. Pause the video now. Can you find the current in this circuit? Just the series one. So pause the video now. When you resume, you should have gotten 0.5 amps. How do we get that? You do 2 plus 2 is 4, and then 2 volts divided by 4 is 0.5, or 1/2 amp. So this current is 1/2. This one is going to be a little different. This one we have to use the fraction formula that we just learned. And this one, each one is 2, so we do 1/2 plus 1/2. 1/2 plus 1/2 is 1. And then 1 flipped, 1/1 is still 1. So the resistance for this one is 1, but we're not done. You still have to divide it and plug it back into this formula. So I'll give you a sec. Please pause the video now. Can you try and get the current of the parallel circuit? When you resume, you should have gotten that this current is 0.5. This current is 2 amps. And based on what you've learned about current, I want you to predict yourself which light bulb set up or which circuit will have brighter lights. Pause the video now. I will go over the answer. in 1 second. You should have gotten that this circuit, the lights will be 4 times as bright because the more current, the brighter the light bulb will be. Okay. Now, based on this video, I want you to finish your homework so you can prepare for the quiz on Tuesday. When your team is done, work on your science area. You won't work on the posters because you won't be in my classroom, but work on either your graphs, or your title, or what else might be in the poster. Thank you, everyone. I hope you enjoyed the video. Have a great day.